Okay, well, first, thank you for giving me the opportunity to talk to you today. And yeah, I shall be talking about sustainability and how it applies to lighting. So if we look at what the definition of sustainability is, ISO Guide 82 defines it as the state of the global system, including environmental, social, and economic aspects in which the needs of the present are met without compromising the ability of future generations to meet their own needs. So the important thing is it covers environmental, social, and economic. It's not just environmental. And it's talking about the people alive now and the people who will be alive in the future. So sustainability may be shown by this diagram, which is normally called the triple bottom line, and it looks at the different impacts. And if we think about the needs of society, you can ask various questions. Is an employer socially aware? Does it treat employees with care and concern? Does it help people develop throughout their career? Does it connect with the local community to improve the area? Does it respect cultures, and does it allow a good quality of life? And these are all the needs of the present, but equally, they're also the needs of the future. So the questions that we ask now will also be the questions our children will ask. And if we don't meet the needs of society today, we are very unlikely to meet them tomorrow. And how we use natural resources has a major impact on sustainability and where we are. As we extract raw materials, it has a significant impact on the environment. It can pollute the local area. It can change or destroy areas of land, and it uses large amounts of energy. And many of the basic elements we use in making products have a finite availability. At some point, they could run out. So if we don't use them wisely, we don't recycle, reuse, or recover them, future generations will suffer. But we have an additional problem, because actually product manufacture uses energy, water, and other resources that we've always taken for granted. And we can't do this anymore. We have climate change, we have drought. There are areas of Spain that are already in drought conditions, and this is the start of the year. Other areas will have floods. So all of our actions contribute to a changing climate. And in many parts of the world, we can no longer meet the needs of the present. And the needs of the future are being very compromised. But you still have to consider the economic impact. A lot of these sort of facts overlap with each other, and the three strands of sustainability are very interdependent. But if you look at the economic impact, if you have a business, it's no use being the greenest, most sustainable, environmentally conscious company that has ever existed if it's not economically viable. The business will just close quickly, which isn't good for the environment. So there has to be a balance. And there has to be an acknowledgement of giving back to society. Nobody likes paying tax, but taxes shouldn't really be a burden. They're part of a social contract between a business and wider society. And technology and innovation will drive society, hopefully, to more sustainable solutions. And in a time of globalization, we need to consider the full supply chain. Any impact on sustainability in any area of the world will affect us because it is a global problem. So it's necessary to balance the needs of the business with the needs of the environment. If it's not possible, either the business is economically unviable or environmentally unviable. But in this presentation, I'm going to focus on the environmental issues. And more specifically, I'm going to focus on production and application, because most environmental impact occurs in the use phase, and after that, in the production phase. This is not a reason to ignore all the rest. It's just, these are the key points. So I will consider environmental aspects with respect to manufacturing and the use of lighting. And we manufacture lighting all over the world in very big factories. We use lighting all over the world, perhaps not always well. And the first thing to realize is we have to minimize the impact of a product. So we need to consider the circular economy. And this is where products are continuously reused, remade, recycled, remanufactured. There is very little material should end up as waste. So manufacture is a continuous process. It leads to use, which leads to remanufacture, which leads to reuse, and this keeps going. But this begs the question, how can we judge a product? How can we decide if a product is more or less sustainable? And one way we can do this is through an environmental product declaration, which provides quantified, standardized information on the environmental impact of the product. And it uses predetermined parameters. So it's created according to a set of standard rules. The source of the product category rules needs to be known because this will have a major impact on the results. So in this case, they come from a European standard called 15803, which is Sustainability of Construction Works, Environmental Product Declarations, Core Rules for the Product Category of Construction Products. And it also uses another European ISO standard 14025. But not only should it use standards to actually do all the calculations and set the criteria, you should consider, is it third-party verified? Is it impartial? Because it's far too easy for somebody to make a product and then tell you how good it is. You really need somebody else to have this discussion and say, yes, we have checked it, the claims are good. And if you look inside an environmental product declaration, it will actually tell you all of the materials that were used. It won't necessarily tell you where they were used and how they were used, but these are all the materials in the product. And this can be useful. So if you look at certain ways of calculating embodied carbon, and this example is a UK document called CIBSE TM65, you can take that list of all the materials and you can use it to calculate embodied carbon in a building service or within a building as a whole. So you can then build up a picture of what the impact of your building is having on the environment. And embodied carbon refers to the greenhouse gas emissions released during production, construction, end of life. It doesn't include operational energy. So if you look at all the different sort of categories of the through life use, it will exclude B6, B7, and D. So it will include the operation and it will exclude beyond the life cycle. This is because operational carbon is not embodied in the product. It's not physically part of the product. If you do a full carbon life cycle for a building, then the operational energy will be included, but it's not included in the product itself. And beyond the life cycle, so reuse, recovery, and recycling are also not embodied in the product, but in principle, they can reduce the impact of the carbon that is in the product because you're then reducing the carbon in subsequent products. Other things that you could find in an environmental product declaration, things such as acidification potential. So this is effectively anything that can create acid rain, for example. So it's sulfur dioxides, nitrogen oxides. It's the acidification potential. We have the eutrophication potential, and this is the impact on terrestrial and aquatic environments, mainly due to things such as fertilization, excess supply of nutrients. These may be low numbers because it's a lighting fitting, but actually there is still an impact because you do have some things such as paper, cardboard, all of these things that come from natural resources. Two that are actually quite interesting are the abiotic resources. And effectively, ADPE considers the non-renewable raw materials. So this is what raw materials were used to make the product and what is the impact. And this indicator is actually based on how much you used and how much is available in the world. So it will self-adjust. If you use a very small amount of a very rare material, it will have a big impact. And the equivalent, which is the ADPF, looks at fossil fuels. So how much energy in the terms of fossil fuel extraction was required to make this product. And the bottom ones are concerned with ozone. So ODP is ozone depreciation potential. And effectively, it's what damage is caused to the ozone layer in the environment. Whereas the equivalent POCP is what ozone is created at ground level. So ozone damage in the environment is a different concept to actually having ozone in the ground level. Ozone at the ground level is not particularly useful and can be harmful. So all of these may be used to evaluate the environmental impact of a product on various aspects of the environment. So they're important. They let you start to make value judgments. But of course, you have to understand what they're based upon. In this case, this is for a street lighting product. It will have a life of 20 years. And over those 20 years, it will be assumed to be lit for 11 hours per day. So these are the standard conditions that are set within the European and the ISO standards to say, when you calculate for this type of product, these are the assumptions you have to make. But if you don't know the assumptions, then you can't compare between products because you don't know what you're comparing. So that describes the environmental impact of the product, but actually design can also minimize manufacturing impacts. So you ensure the most efficient and sustainable production techniques. You ensure the design allows reuse, remaking, recycling, and it uses recycled content. You can minimize the supply chain complexity because as it gets more complex and it becomes more global, not only does it have a bigger impact, it's very hard to trace what your impact is overall. If you have a simple supply chain, it's easier to trace the environmental impacts for the final product EPD. But we have to be honest about sustainability. And the reason is that there is also the concept of durability. Will it ever fail? Will it ever break down? And they are not the same thing. One of the problems is if you have a very durable product, you may not need to make it repairable. So there was a European project called RetroLite, and it looked at the balance between repairability and durability. If a product only rarely fails, the additional material that you have to put in to make the product repairable may actually exceed the environmental saving from a product being repaired. And they did lots of examples. So it's got a number of case studies. And in the case study that I picked out, 1 in 100 luminaires will fail. But of these, 75% of failures will be due to the electronic driver, and only 25% will be due to the LED module. So actually only 1 in 400 LED modules will fail. So then if you look at 4 failures, only 1 is because of an LED module. So in one design, they said only the control gear is exchangeable, which is normal today, but the LED module isn't. So when you have one luminaire that fails due to the LED module, you have to replace the luminaire. The other 3, you can replace just the control gear. If you compare that to a design where it's equipped with an exchangeable LED module, so you can repair all 4. The one where the LED module replaces, you can put in a new LED module, you can replace the electronic drivers. However, there's additional material consumption to ensure the exchangeability, so you have to put in plug-and-play connectors. And life cycle analysis can show that the contribution of the additional connectors is just 0.4% to the abiotic depreciation potential. But that 4% over 400 luminaires actually means that it's more resource intensive than just replacing the luminaire. So actually, you have to consider the real situation as opposed to what sounds good. It will vary by product type, it will vary by application, but in some cases, repairability is essential. In some cases, it can actually create more problems. So repairability does not come for free, and we've got to be honest about sustainability and how durability may mean sustainability is not the same as repairability. And we also have to look at typical lifetimes, because a lot of spaces have typical refurbishment times, and they will vary by application. So it's no good designing for repairability if a space will be refurbished more quickly than the product is likely to fail. If you have a product that has a 100,000 hour lifetime but is only expected to be used for 50,000 hours, then it may actually be less sustainable to make it repairable. So there's lots and lots of things that you have to think about, not just it has to be repairable. Does it need it? Is that the best solution? And one of the problems with an environmental product declaration is it can miss some factors out. They remain unseen because they're related to the production process and not necessarily the product. For example, how much energy is used via renewable sources. And this will vary by production site location, because some countries have more renewable capacity than others. And it will vary depending on the weather. If you rely on solar generation and it rains, you don't get much solar energy. If you require wind generation and it's a hot windless day, again, you don't get much renewable energy. So it's a moving target, but you have to try and go for the best. And how much CO2 is emitted by the production plant and how this relates to the number of products produced. And production will always have waste material. No matter how efficient you use a resource, if you have a big sheet of metal and you punch parts out of it, there will be a bit that is left. And this waste isn't necessarily counted as part of the product. So what happens to it? And it will vary depending on the product mix. It's difficult to measure, but it's important to understand, is it even measured and used within the production facility? So if you don't measure it and you don't understand it, you will continue using bad practice. So that was looking at production, but now we can look at application. And application is where most of the energy gets used. And the most important point is only use light when it's needed. We waste a lot of energy by not turning lights out. People need light. Empty buildings and outdoor spaces do not. And if you leave the lights on when they're not needed, not only are you using energy, you're actually using up part of its useful life. If a product will last for 100,000 hours, but you spend 30,000 hours lighting an empty space, that's 30,000 wasted hours. The product will fail much earlier than it needs to. We've had lighting controls for a long, long time now, but too many people don't use them. And even if they have been installed, they override them. And people have to understand lighting controls. I was giving a talk in a school, and to demonstrate lighting controls, I dimmed the lights in the classroom up and down. The teacher was amazed. The teacher didn't know you could do that. So we don't tell people what exists in their spaces. And also, lights don't have to come on when you enter a space, because normally they're not needed. If you're enter a space that's got lots of daylight during the day, you just want the lights to stay off. So you should have to actively do something to turn the lights on. We also have to value lighting design, because it's important the lighting has been designed, installed and commissioned correctly. That will make for the more efficient system. And we also have to understand that lighting is related to a task, and we don't always do the same task all the time, every day. So as you change task, can you change the lighting? You may not need so much lighting. Why not turn it down? And then we get into pollution, or more specifically for us, light pollution. And the European Environment Agency specifically mentions that the introduction of energy into the environment is classed as pollution. And because light is energy, light is pollution. And light pollution is a major problem. By using too much lighting or using it badly, we are damaging the environment. So effectively, we have climate change, but we're making it worse. What the climate change is not harming, poor lighting is. And if you want to look at it a different way, if you turn all the lights out, you will instantly see the stars. Any ecological damage that we have done because of the lighting will take much longer to repair. It is not instant. It can take weeks, months, years, decades. So the damage we are doing by the lighting is for the long term. And to an extent, we have created the problem. The more people are used to light, the more afraid they become of the dark. And we've lost the sense of beauty of darkness. We don't think darkness is beautiful, we think darkness is dangerous. But actually we have to be socially responsible, because darkness will discriminate against parts of society. People who feel unsafe going out because age, vision, mobility issues, women. If we reduce the lighting, they may not feel safe to go out. So we have to do it carefully. We have to accept that some people need light. When they're not there, we don't need the light. We also have the problem that some people can't bear the light. We have some people that find it really difficult to be under certain types of lighting, and we're very bad at dealing with that situation. But many existing lighting installations are long overdue for refurbishment. And the technology they use was good practice at the time. It would generally now not be permitted under current regulations and standards. Older products using lamp technologies that were more difficult to control optically create more stray light. If you want to do good optical control, the best you can get is a point light source, a very, very small light source. As the light source gets bigger, it becomes harder to control. And mounting methods have changed. We would mount methods that tilted the luminaire upwards, but that distributed more light upwards into the sky. And the way of using optics, such as dish diffusers, to actually allow greater spacings also created greater light pollution. If you take a product and you look at it and you slowly rotate it, the point that you will get light cut off is when you can no longer see the optics. So if you have a big dish bowl and you can still see it when you're above the luminaire, then light is going above the luminaire. So we're using lots of energy by putting light in the wrong places. We can do a lot better. With modern technology, modern optics, we could control the light much better. And then with good design, we can use these products properly. In a way, this can create its own problems. People are used to lots of light scattered around, making brightly lit nightscapes. And many people don't consider that as wasted light or the problem. It provides them comfort and safety. So if you light to the new standards and with new technologies, we can create a better environmental solution, but the perception may be poor compared to the older, less efficient technologies, because we are used to bright spaces as opposed to correctly lit spaces. And then we have to consider the ecology. So the wider implications of light at night, both for people and ecology. These are 5 rules that actually came from a paper on reducing the ecological consequences of nighttime light pollution options and developments. But they're very good at covering the question, should we light? If we do light, when should we light? And if we do light, how should we light? So if we look at the first thing, the question is, do we need light at all? And one of the things that we need to understand, there is very limited information about what creates a truly dark space and how big that dark space should be. And these factors will probably change by species, as some species will travel a greater distance than others when foraging, for example, so they're going out for food. If the space is too small, even if it's dark within that space, any colony will generally die out because there isn't enough space to have a good food chain. So the area of dark space we need will vary. And we have to understand that humans are actually fairly insensitive to low lighting levels compared to other animals. So to create a space adequately lit for humans will result in a space overlit for animals. So to adjust for animals in nature, you will create no-go areas for humans. Many humans will not go out into dark spaces, especially the elderly, people who have inferior night vision. Human vision can be up to 4 orders of magnitude less sensitive than that of other species, and especially at night using rod receptors, it's one of the least sensitive visual systems known amongst animals. So if we reduce the lighting, it is still too bright. We come back to the thing, light where needed. A large amount of light pollution actually comes from buildings. As we've changed the way we've constructed buildings, we have large areas of glass, which means we get lots of spill light. And this has become a major problem, and especially because generally spaces are empty, but the lights are left on. A lot of cities are trying to do something about this. So the City of London has actually introduced a new regulation that at the moment is voluntary to say you have to turn the lights out at night. We could limit the duration of the lighting. The trigger points for most diurnal and nocturnal species is around the hours of sunrise and sunset. So the mechanism for adjusting activity times is the presence or absence of light. For an example, if a nocturnal animal emerges early during the daytime hours, its body clock will self-adjust, it will sleep a bit longer next time and come out when it's dark. So creating a life curfew is difficult. People generally need lighting during the period of most change in ambient conditions. So especially at dusk, but also to a lesser extent at dawn. And these are the critical periods for animals. So if we limit the duration of lighting for animals, it won't work for humans. If we limit it based around humans, we will shorten the night for animals. And even if you control the spectral output from a luminaire, if you don't control the distribution, it has limited benefit. And differing species may react to differing spectral bands, so there's still an impact, even if it's reduced. There is no such thing as ecologically friendly light. We can just be as friendly as we can. Because remember, humans are insensitive to light. So street lighting levels are significantly higher than light from the moon or stars. The minimum acceptable light level for people is far in excess of the maximum acceptable light level for animals. So 0.3 lux is effectively a full moon directly overhead. 0.1 lux is a full moon not directly overhead. And if we look at all of the different things, such as animals, bees, insects, and how they react to light, then we have photosynthesis. There's a peak in the red area and a peak in the blue area. If we look at sort of a generic insect, it has a peak in the UV, but also a bit of a peak in the green. And if we look at bees, their peak sensitivity is in the green. So when we do lighting, And here's an example of a light spectrum as it changes through time. We can change it from a intermediate white to a warm white, and that means that the blue content will decrease, but actually around some of these areas it won't make a difference. So just changing the spectrum isn't enough. We also have to dim it at the same time. Change the spectrum and dim, then you're starting to make an impact. And you can see the benefits of LED compared to some technologies. So they did a study in the Tyrol region, and that showed that 3000 Kelvin LED attracted significantly fewer insects than other sources. It also showed that 6000 Kelvin LED attracted fewer insects than other sources. And this is basically because the old HID technologies, they have a component of UV or IR, whereas LED do not. And a lot of insects and animals are attracted by UV. But you can get side effects that you don't expect. So changing the light spectrum can change the ability to discern types of flowers or types of insects. So if you like, purely in terms of impact on the species, yellow or orange light might be the best, but this will have a knock-on effect in other areas. For bats, red light might be optimal, but if it disturbs the wider food chain, then the bats will still die out. One of the impacts that you can get is you can get the idea that insects and animals can't camouflage themselves. So if they're awake during the night, they will then find somewhere to roost during the day. And if they can't detect colors properly, they will pick somewhere that isn't suitable, and they will then get eaten during the day because they're too visible. So changing the spectrum, we have to accept that moonlight is white light. Changing the spectrum to one color, making it monochromatic, might have different side effects. And we have a big concern about the circadian system. Light at night will impact the human circadian system. It has a peak sensitivity at short wavelengths. But one of the things that you always have to think about is light in lux is a human response. Animals don't see light. When we talk about light, it's based on the Vielander curve. It's based on the human eye response curve. Animals don't see light, so measuring things in terms of light could be a problem. And actually considering street lighting, in some experiments, they basically said that if you sit and look at a street light for 1 hour, unless it's quite a cool sort of Kelvin street light, it won't make a significant difference. People don't look at streetlights for an hour, so you're more likely to have a major impact of what you do in your house than what you've done with street lighting. So we have to consider we live in a modern world. Light at night is just one part of this world. We've moved to a 24-hour, 7 days a week, highly technological lifestyle. And this urban lifestyle is quite recent. Humanity and ecology is not adapted to it, and it's causing problems. At some point, we have to decide what we're willing to accept and how much we will reject in our modern way of living. And we need to take a wider view on perceived benefits, negative impacts, and how many people are affected in which ways. Everyone is different. One person's concept of nuisance is another person's concept of safety. We need to put light at night into context of what we're willing to give up or change, because light at night is now part of our society and culture. And that's in a way much greater than people appreciate and understand. You can argue against lighting in a supermarket car park because it's a remote, but if you want to turn the lighting off in your street, people get worried, people get nervous. And then you have shopping, watching entertainment, flying on business, going on holiday. All of these things use light. And even at the smallest level, such as watching television in bed or working on a computer late in the evening, what are we willing to give up to actually make our world more sustainable? We can no longer light everything without thinking about what we really need as opposed to what we want. And we can no longer compromise on sustainability to save money. We have more sustainable product solutions. We can do more sustainable application designs, but what are we really willing to do? And that is the question I will leave you with. Thank you.